Hello and welcome back to Statistics with Dr. Platt. And today in this session we're going to be looking at several ways to display data. The first two of these are useful for relatively small data sets and do the job of preserving all of the original data, which is relatively unique amongst our data presentation methods. They are the stem and leaf plot and the dot plot. A semi-retaining data display is the frequency distribution and associated graphs. And in future videos, we're going to be looking at relatively destructive methods where we're going to be summarizing things down with a small number of different numbers depending on the circumstance. So let us get started. A stem and leaf plot uses the root or the stem of the number, which is everything to the left of the smallest represented digit of the data. Generally this is going to be whole numbers, but it can be decimals, in which case the lowest decimal part will be in the leaves, and everything else of the number will be in the stem. These numbers which represent the number of points scored on the first week of the 2022 NFL professional football season. And we have single digit numbers, 0 in the tens place, 3, 7, 7, and 9. And a large number of two-digit numbers, where the 2 would be in the tens place, representing 20, and the 0 would make it 20 even. We have 4 of those, 21, 2 of those, a 22, and so on, with one team scoring 44, a 4 in the tens place, and a 4 in the units place. A dot plot also preserves the values, and instead of writing them out in this manner, we have a number line, and above the number line we're going to place a point for each data value that occurs in the set. If we have 3 data values that will represent the same number, let's say 5, then we have 3 dots, one above the other. Both of these, as I said, preserve data and are useful for fairly compact and fairly small data sets. Data sets that are extremely wide would end up needing very large dot plots or stem and leaf plots. And if there's a lot of numbers, it can become a little bit challenging. They're a useful tool to help us organize our data by hand. With the dot plot, you scan over the data for what seems to be your least and greatest values. You draw a number line with a little bit of room to spare on both sides, from the least to the greatest, and put a dot above each point where you find a data value. If you need to expand it, you can go ahead and do so. Or with a stem and leaf plot, you can start out with each decade or each group of 10 and write all your data, the units place of all your data values, and then go back in and organize them in a second draft. A frequency distribution is a table of values that is used to organize the number of frequencies of different types of data. If this data is categorical or qualitative, then we have the quality name in our leftmost column and the frequency of occurrence in our next column. If, however, as is most common, we're dealing with qualitative data or quantitative data, things are a little bit more complicated, and I'll go through it step by step. But we're going to have a range of values in each class. It can be one value up through a fraction of the total area of the total region marked off by the data. First thing we need to figure out is the range of the data that we have present. And this is the difference between the maximum and minimum values in the data set. This allows us to, along with a value determining the number of classes or the number of bins that we're going to be using, allows us to find our class width, which is found by taking the range, dividing it by the number of classes you want, and always going up to the next integer or next whole number. Even if you land on a whole number, you still have to go up. So that way you have enough room. The respective lower class limits are the smallest value that can fit in a class, while the upper class limit is the largest value that can fit in a class. Our upper and lower class limits are the same unit of measure or the same size as the data values. So if all your data measurements are in whole numbers, then your upper and lower limit will be in a whole number. However, there's an interval between each whole number, and for various reasons, we need to close that, and we create class boundaries. And our class boundaries will be halfway between the upper and lower limits, or the lower limit of one class and the previous upper limit. Okay, so let me toggle here. So we have the class name can go here. The lower bound can go here. The lower class limit, class midpoint, upper class limit, and upper bound can go here, and then we have our frequency. So we can class name 1 or I, our lower class limit. Let's say if we have only. So we have our data that runs from 3 to 44. The total range is 44 minus 3, or 41. And if we want to go with 7 classes, we're going to divide 41 by 7, and that rounds up to 6. So our lower class limit is our least value. We'll call it, it's 3. And then the difference between one lower class limit and the next lower class limit is our class width. So this is going to be 3 plus 6, or 9. 15, which is 6 more than our previous, 21, 27, 33, and 39, which looks like it might be too few, but we will see in a moment. Our upper class limit is 1 less than our next lower class limit. So 1 less than 9 is 8, 1 less than 15 is 14, 1 less than 21 is 20, 26, 32, 38, and 44. By rounding up, we had just enough room. And the gap between 8 and 9 can be split in two at 8.5. Between 14 and 15 is 14.5. And this gap is 4 units. 20.5, 26.5, 32.5, 38.5, and 44.5. Each of these upper bounds also represents a lower bound, except for the highest upper bound, and our lowest bound is half a unit below our lower class limit. All right, we're going to stop here for a moment and resume with constructing a frequency diagram in our next video.